Hello everyone, welcome to the next lecture on the PY question series. Today I will explain you how you can solve the limits question. Myself Dr. Harish Garg. You can follow my YouTube channel where you can find the playlist of CSIR UGC net and you can see the various lecture related to the PY question series is available in this playlist. All are explained with the help of the shortcut tricks. What is the objective is? We will cover the 45 plus question in this lecture related to the topic function of the function, limits of the function. I will explain all these questions with the help of the shortcut tricks. I hope you can subscribe my YouTube channel so that when I upload it my next lecture, you will get the notification. Now, the only one tip that will work for you to solve any problem is this one. What is that? Whenever there is a question related to the limit of the function, then your main target is to check whether this limit x approaches a of fx existence or not. And if it is existence, whether it is unique or not. Whenever these two conditions satisfied, then you can say limit of the function exists. Otherwise, the limit does not exist. Secondly, if you are working on the sequence like xn, then we will find the limit infimum, we will find the limit supremum. If both are my same, then only you can say the limit of the function fx exists. If the limits of the infimum and limit of supremum are not equal, then we can say limit does not exist. That's the only tips for you, that based on my single tips, I can solve 45 plus question in this lecture. So let's see. Based on these limits, after completing this limit, I will explain you the questions on the PY questions of continuity, then PY questions on the uniform continuity, and lastly, we will cover the PY questions on the differentiability. But make sure I will upload these three lectures if I get a good response on this limit lecture based on likes and comment. If I get a good number of likes and comments, then I will upload my next video very soon. If you are new to my YouTube video, you can scan and join my WhatsApp group. Now you can see as n approaches infinite, we are talking about the limit. Always remember my shortcut tricks that you can solve this problem with the help of the 10 to 15-second time period. What is my shortcut tips for you? Whenever you have a limit x approaches infinity, 1 plus fx raised to power gx. You can see all these functions are of the form 1 plus fx raised to power something. If this is of the form 1 raised to power infinity, then you can find the limit directly by taking limit e raised to power limit fx into gx. That's all. There is no thinking about what is the formula for this exponential, what is the formula for this. Just look about that. When you take an infinity, 1 plus 0 is 1 raised to power infinity. So that means I can apply this rule. Exponential of limit fx is my 1 over n into n plus 1. So what is the limit as n approaches infinity? Is infinity by infinity form. So it is e raised to power 1. That is my e. Similarly, second question, it is again 1 raised to power infinity form. So I can find the limit n over n plus 1. Again, it is a infinity by infinity form. I can apply the L'Hopital rule. This is again e. Again, you can see it's a 1 raised to power infinity form. So your answer will be e raised to power limit fx into gx, that is by n. So that comes to be the e raised to power infinity, which is infinity. That is not correct. Look at the last one. Again, this is the form of the 1 raised to power infinity, e raised to power limit fx into gx. So when you take n approaches infinity, it is 0. E0 is my 1, but this is my 1. So the right answer of this problem is A and B are the correct answer. Again, you can see this is the form 1 plus fx. But you can see it's a logarithm. I can write this n raised to power. I can write this n plus 1 also in the form of the n plus 1. This is by n square. I can write in the power. This is n. I can write in the power. Now again you can see the same shortcut tricks will be applicable. Why? Because it is again in the form of 1 plus fx raised to power gx. Now clearly say only this quantity. This is of 1 raised to power infinity. So what is the right answer of this? Log, because it's a log, then e raised to power fx into gx. Fx into gx is 1. So what is the right answer of this? Log of e raised to power 1, that is 1. Similarly for second question, log e raised to power fx into gx, n plus 1 over n. If you take the limit, then it will be e raised to power 1. It is again 1. Look at the third option. Again, it's a log e raised to power 1 fx into gx. That is my n. So if you take limit as n approaches infinity, this will goes to the e raised to power infinity. That is my infinity. But he said 1. Similarly, for the last case, you can calculate the log e raised to power 1 over n. That will goes to log e raised to power 0, e raised to power 0 1, log 1 will be my 0, but he said 1. Again, the right answers are A and B are the correct answers. You can see within the 10 to 15 seconds you can solve this problem. Now, can you solve this question within the 5 seconds? You can solve it. I will give you the 5 seconds. If you are able to solve this within the 5 seconds, put a like on this video so that I can understand it. You will learn the concept very well. Now the 5 seconds is over. Now you can see again it is form of the 1 raised power infinity. So I can say e raised power fx. What is my fx in this case? Minus 1 over x square n square, and gx will be my n. So it will be my minus 1 over n. When n approaches infinity, it is a 0. E raised power 0 1 is my right answer of this problem. Don't forget to like and comment on the video. Now again you have to find the limit, but is it in the form of the 1 raised power infinity? No. So your target is to find the value of the log x divided by x raised to power half and log x divided by x as x approaches infinity. Now you can see about the first part. This is my infinity by infinity form. Then I can apply the L'Hopital rule. It is my 1 over x divided by 1. That is 1 over x. It goes to the 0 as x approaches infinity. Clearly say this limit is my unique and existence. So therefore, this value will be 0. That's the infinity. Wrong. Limit does not exist. Cancel. Now similarly, again it's an infinity by infinity form. I can apply the L'Hopital rule. It is half root of x. I can write this number is 2 root x over x. That means 2 over root x. What is the limit as x approaches infinity? This will goes to the 0, which is unique and existence. So therefore, infinity will be cancelled out. Third is the right answer of this problem. Now look at this another one. What is the shortcut tricks for such kind of the problem? Remember, you can solve this question in the 5 seconds. How? Just think that. What is the difference between these two quantities? I will find the firstly difference. I will find the difference between the each quantity. This is 2, this is 2, this is 2. So that means if I say my difference is D, then the answer of such kind of the problem is always 1 over root D. Make sure it must be 1 over this quantity and 1 over root n. So what is the answer of this problem is 1 by root 2 is the right answer. And you can see within the 5 seconds you can solve the problem. Second method is, instead of applying the shortcut tricks, you can rationalize them. It will be my minus 1 root 3 over minus 2, then plus root 3 minus root 5 over minus 2, and so on. And the last value is 2n minus 1 minus 2n plus 1 over minus 2, and 1 by root n is outside. And you can see root 3, root 5 all are cancelled. And if you again solve them, answer will again be 1 by root 2. But I always suggested you can apply my shortcut tricks. Can you solve this question again in the 5 seconds? If yes, put a comment. What is the answer of this problem? What is the difference? 2. Difference 2. Difference 2. What is the right answer of this? 1 over root common difference. So the right answer is B is my correct answer. Now, another thing. What is the shortcut text for such kind of the problem? When the statement will suggested you limit n approaches infinity and summation part. You can see that two quantity available. Whenever these two quantity available, you can always write in the form of the 1 over n. So now I will try to firstly write in terms of 1 over n. Since 1 over n is not given, I can multiply and divide by n. It is 1 over n, then it is n square over k square plus n square. I can write this number is limit n approaches infinity, summation k varies from 0, 1 over n. I can write this term is k square over n square plus 1. Fine. Then you can substitute the term k over n is my x. Then what is my 1 over n into dk? That is my dx. So 1 over n over this k will be my dk, that is a dx, and this quantity will be 1 plus x square. Then the only thing is how you can calculate the limit. Substitute the lower limit. In this case, what is the x? 0. When you substitute the upper limit n, the value of the x is 1. Now can you integrate them? This is my tan inverse x from 0 to 1. The answer will be pi over 4 is my right answer of this problem. Again you can see this is my limit, n approaches infinity, and summation j varies from 0 to 2n minus 1. I need to write 1 over n. What is the remaining thing is j cube and n cube. Fine. I have written n4 in this manner. Then I can take j over n is my x. So this value will be 1 over n dj will be dx. It is my x cube into dx. What is the limit? When j is equal to 0, x will be 0. When j is equal to 2n minus 1, then take limit n approaches infinity. What is the limit of this? It comes to be 2. So the upper limit is my 2. That is the limit of the x. Fine. So x will be my 2. Now can you integrate them? It is x4 divided by 4 from 0 to 2. So that means 16 over 4. 4 is my right answer of this problem. You can see I have solved all these 6 questions with the help of the shortcut tricks. I hope you can like and comment on this video. I will upload the next video, PY question of the continuity and differentiability based on comments and like. F is a monotonic, non-decreasing functions on R. F is my R to R. Then which of the following statements are my correct? Remember that you take any function, say any function is my 1. The easiest function is my 1, or you can take an as another easiest function is x. So look at the first part. Limit x approaches a fx existence. Yes, true. It's existent because it's a continuous constant function. But based on the counter example, your target is to discard the option. Look at that. What is this function is? Bounded function. Fine. This function is a monotonic. This function is my non-decreasing, because if you look at the graph, its value is my minus, its value is my plus 1 from minus infinity to plus infinity. It's a non-decreasing, but this function is bounded. So third option is cancelled. Look at this option. If I take f of x is my x, then what is my g? G is my e raised to power minus x. Does it bounded? It is unbounded because my domain is minus infinity to plus infinity. If I take x is my minus infinity, what is the answer of this? E raised to power infinity. That is unbounded. Once it is unbounded, he said bounded option is cancelled. Now, what does the meaning of this? Limit x approaches a fx exists. That means, what does it mean? Limit is my unique. Fine. At each point A. But can you think about any other example or any other graph? whose limit is not unique, whether the function is continuous. Is it given to you? No. So you can think about the discontinuous function. That's very simple. Look at that. I have taken 0 to 1, 1 to 2, fine. And you can see this function is my discontinuous at 1, fine. So what is the function name? That is a step function. So what is the limit? Fx at any point, any integer point. That means limit does not exist. Why does not exist? Because you can see the left hand limit is my 0, while this number is say my 1. So the left hand limit is my 0, the right hand limit is my 1, which are not unique. Therefore this is my does not exist, but he said existence. So this option is cancelled. Only left behind is B is my correct answer. F is a continuously differentiable function on the R. Which function you can take any continuous function? One is one of the easiest way, or you can think about f of x is by x. So let's say if I think about this term, what is the value of the L? Limit x approaches infinity, fx plus the derivative, that's a 1. What is the limit is? Infinity. But we need a fx is strictly less than infinity. So that means this example does not work. So let's verify whether the constant definition is appear. What is the L in this case? Then what is the f dash is 0. So L will be 1. Fine. And you can see it's satisfied. Now look at the options. You can start from the below. Limit fx existence, yes, because the limit is always 1. That's a unique, satisfied. And limit of the f dash is L. L is my 1, but f dash limit is 0. So this option is cancelled. Limit of the f dash exists, yes, because the limit is always 0 and it's a unique, and the limit of the fx is 0. But what is the limit of the fx? 1. This option is cancelled. Fine. Now out of the two option I have to discard one of them, and the other one will be the correct option. Now what is the option 1 suggested you? That he suggested limit x approaches infinity, f dash exists and is equal to 0, while the second part will suggested you that limit x approaches infinity, f is my L is my 1. Fine. If I prove that this is not happening, then it means this is the correct option, which is the left behind. Or if I prove this is not true, then this is my correct option. Now look at that. First, assume that this hold. Assume that this hold. Then I can substitute this value at this point. L is my 1. Then it means limit x approaches infinity, fx. Fine. If I solve this one, substitute this, L is my 1, limit is my 1, then limit of the f dash. That means limit of the f dash is my 0. What you conclude from these two cases? That means if this happen, then this implies this term, and if this happen, this implies. So that means this is both if and only if. That means both are my correct option of this problem. Look at this another one. F R positive is a set of all the positive real numbers. Suppose R positive is a differentiable function. Can you think about any of the differentiable function? Constant function is always differentiable. Then your gx will be e raised to power x. Fine. Then firstly we can check about fx. If limit of the fx is 0, that is not true. Okay. This is f dash. This is a 1 plus 0. It is not true. F dash is by 0. Yes, it's satisfied. So if f dash is my 0, that is satisfied for this example, then the limit of the fx is also 0. But that's true. Limit of the fx is my 1. Fine. So third option I have discarded. Now the rest of the examples, this case is not applicable. So now we can think about the other example. Now look at the first one. First one suggested you the limit x approaches infinity of f is my 0. That means limit is existence and unique. Fine. So, and the derivative will be 0. So look at that. What is the function f? This is my gx over e raised to power x. Or because in the first case there is no need of the f. Fine, there is no need of the g. Now think about that. When what should be the function of the f? When you substitute x infinity, it will goes to the 0. So definitely the denominator term will be x. Fine. Then what will be the case of the numerator? The numerator case will be either the constant or any bounded function. Any bounded function. Because if you taken as a bounded, for example, sine x, fine, then I can easily write this is 1 over x and it is minus 1 over x. Then as x approaches infinity, by the sandwich theorem, it will goes to the 0. And if you taken as a constant, then it will again goes to the 0. Then there are the two cases. Look at that. If I take f is 1 by x, then this property is satisfied. What is my f dash? Minus 1 over x square. It also satisfied. Can this property also hold for the bounded? If it is also hold for the bounded, then we can say this first part is correct statement. So look at that. If I take sin x over x square, what does it mean? If I prove that, if I prove limit of the f dash is not unique, what does it mean? That means limit does not exist, then this option will be cancelled. So what is the f dash? I can take u over v is a cos x over x square and minus 2 over x cube sine. Okay, fine. I have used the product rule. I have taken sine x and 1 over x square. Fine. Now you can see when you take limit x approaches infinity, again this is the bounded function, this term goes to the 0, this is the bounded function, this goes to the 0. But just think about that, this is x cube. If I consider instead of the x, if I consider this is my, if I simply x and x square, if I replace them by x and x square, then what will be the derivative is 2x cos x square. Fine. If I taken this is x square and this is x and minus 1 over x square into sine x square. Then what is the limit? This limit will goes to the 0 because this is my bounded function and this 1 over x goes to the 0. You can see this term will goes as cos x square. What is the limit x approaches infinity? Any number lies between minus 1 to 1. That means it is not unique. Once it is not unique, that means limit f dash does not exist. Once it does not exist, it can never be 0. Fine. So based on this, I have discarded the first and the third option. Now look at the second option. In the second option, I need a f dash. So what is given to you? G is my e raised to power x into f. I can calculate the f dash. This is e raised to power x into f plus e raised to power x into f dash. Or I can written as f plus f dash is g dash over e raised to power x. Now, the second part suggested you if the left hand side is my 0 as the limit x approaches infinity, then g dash over e raised to power x is also 0. Fine. Now, then very simple. What thing come in your mind when you think about the term gx minus x fx or gx minus, that is a Cauchy mean value theorem. If you remember that, g of b minus g of a over f of b minus f of a, this comes to be g dash over f dash. So now you can see g dash, I can take a g is my g, f is my e raised to power x. This property is satisfied. Fine. So I can say this term is nothing but gx minus gy divided by e raised to power x minus e raised to power y, which is 0. So therefore this result true. Now look at the fourth result. If limit, again this part will be 0, So that means limit x approaches infinity, g dash over e raised to power x will be 0. Now, once this will be 0, your target is to find the fx. Clear? Now, as x approaches infinity, this denominator term will always goes to the infinity. So that means what is the nature of the g dash? G dash is either the constant or it will be my bounded. Then only it will be goes to the 0. Fine. Now we can consider the two cases. If g is my constant, fine. Then what is my fx? G is my constant, say k over e raised to power x. What will happen if x approaches infinity? That will goes to the 0. If I take g is my bounded function, so say g is my sin x, for example, then sin x over e raised to power x. Again, it goes to the 0 because it's a bounded, it is less than of 1 over ex. So in both the cases, it will be 0. So the right answer of this problem is B and D are the correct answer of this problem. Okay, now it's a polynomial. First of all, what is given to you? You can read them. Px is a polynomial of the degree 2. Lambda are the distinct non-zero real numbers. Okay. What is the shortcut fix is? If fx is a polynomial of degree n such that there exists at least n non-zero distinct number. Fine. Then if this property hold, then limit as n approaches or fx, let's say x approaches infinity, fx and f dash both exist for all x belongs to the R. Remember the word for all. Now, fx p and x is a polynomial of degree 2. Now, I need at least two non-zero distinct root. I get a two non-zero distinct root. Sorry, one more condition, I forget that. Such that the limit of the functions at these distinct root are existence. Then you can say the f and f dash existence for all x approaches, x belongs to the R. Now you have the distinct roots, limits of the function at these distinct roots existence. Then PNS existence for all x, fine. Derivative existence for all x, finite. Now lambda 0 and lambda 1 belongs to the R. Then lambda naught plus lambda 1 over 2 is also belongs to the R. Lambda naught and lambda 1 are my distinct. So therefore, this Pn of this term also existence for all x, but the question suggested does not exist. Wrong. Derivative does not exist. Wrong. So the right answer of this problem is A and B based on this simplest approach. You can see the next question. Pnx is a polynomial of degree 2. We get at least two distinct roots. So that means we have get a three distinct rule and the limits are finite. Finite, that means the limits are existence. Once the limit is existence, the Pns existence for all, fine. Derivative existence for all, fine. This is because these are my real numbers, so this does not exist cross, this is cross. So right answer is A and B are the correct answer. Now look at this one. An is defined to be, your target is to find this limit. Make sure you are unable to take the value of the limit 1, 2 and so on, because your target is to find the limit also. Firstly, you can integrate them. What is the an? If you integrate them, it is minus 1 over x square. Fine. From n plus 1 to n. I can take minus half is outside. If I take the LCM, if I substitute the upper limits and the lower limit and then take the LCM, you will get this expression. If I open this bracket, then it will be 2n plus 1. I can adjust the negative sign. 2n square n plus 1. whole square. Now you get the an. Now look at the first option. Take any number which is greater than 3, say c is equal to 4. Then what is my limit as n approaches infinity? I take c is equal to 4. This is my n raised to power 4 into this 1 n square, and n4 will be cancelled. It is n square 2n plus 1 divided by twice of n plus 1 square. Now clearly say the degree of the numerator is greater than of the degree of the denominator. So as n approaches infinity, this will go to the infinity. But he said 0. Second option, c is equal to 3. When you take c is equal to 3, that means you have to multiply this by n into c. Fine. So when you take c is equal to 3, it's n cube. 1 n square will be cancelled out. So that is n into 2n plus 1 divided by 2 n plus 1 whole square. That is the limit n approaches infinity. So what is that happen? It's a n square. If you divide them, divided both sides by n square, the limit will be 1. So that's the correct option. When n is c is equal to 3, limit is 2. That's a wrong answer. Check about the fourth. C lies between 0 and 3. Take any number, say c is equal to 1. Then limit n approaches infinity. C is equal to 1. So it will be 2n plus 1 into 2n of n plus 1 square. Now clearly say degree of the denominator is greater than of the degree of numerator. So when n approaches infinity, it will goes to the 0. So that option is cancelled out. Only B is my correct answer. Now look at this another one. Alpha is my greater than equal to 0 with any number. You can choose any number alpha. Say alpha is equal to 0. Then if you before solving look at the answer. If alpha is 0, the answer will be 1. This is again 1. This is again 1. So you are unable to distinguish between the answers. So I can choose the another alpha. If alpha is 1, you can see whether your answers are different. It's a 1 over 2. It's a 1 over 2. It's a 1 over 3. You can see both answers are same. That means again, it is not easiest task to choose alpha is equal to 1. Alpha is equal to 2. 1 over 5. 1 over 3. 1 over 7. Now you can see all are my different. So I can choose alpha is equal to 2. What is my an? 1 plus 2 square up to n square divided by n cube. Now in the numerator, your target is to find the limit as n approaches infinity of an. What is the formula for the numerator? n plus 1, 2n plus 1 divided by 6 into n cube. Now the degree are same, so I can divide them, divided both side by n cube, or you can apply the L'Hopital rule. So it's a 1, it's a 1, it's a 2 divided by 6. Answer is 1 over 3. So which is the case? Third is my right answer of this problem. And you can see that this limit is my unique and existence. So the limit does not exist is option cancel. Look at this another one. P of x is a polynomial of the form a0, a1x plus a2x square such that a0, a1, a2 belongs to the R. a2 is my non-zero. But what about the a1 and a0? It can be any number. So I can choose a2 is my 1, a0, a1 is my 0 for the easiest calculation. What is my px? Px will be my x square. Fine. Now once you know the px, calculate the e1. Integration from 0 to 1 of the px minus half p of 0 plus p of 1. So what is the integration of this is 1 over 3 minus 1 over 2 minus 1 over 6. Calculate the e2 again from 0 to 1 x square minus p of half. P of half is 1 over 4. 1 over 3 minus 1 over 4. 1 over 12. Now look at the answer. I need a absolute value of the E1. 1 over 6. I need the absolute value of the E2. That is 1 over 12. Now look at the first option. E1. Is it greater than of the E2? Yes. because you can see 12 is greater than 6. E2, E2 is my second option. 1 over 12, is it greater than of the E1? That's a wrong option. E2 and E1 are same, wrong option. Twice of E1, if you twice of them, it will be 1 over 3, which is not same of this case. So the right answer is A is my correct answer. Another problem, again, Px in this case is a Fx. Fx is given to be A0, A1 plus A2x square. Again, it is given that A2 is my non-zero. Again, I can choose Fx is my x square. Fine. I can choose again A2 is my 1 and rest numbers are my 0. Then calculate again the E1. Integration from -1 to 1 of the Fx minus f of -1 plus f of 1. What is the integration of this? 2 over 3 minus 2. 6 minus 2, 4. What is the E2? Again from -1 to 1 x square minus of half f of -1, 1. F of 0 twice of f0, 0. F of 1 is 1. It is again 2 by 3 minus 1 minus 1 over 3. Again, I need to calculate the mode of E1, 4 over 3, mode of E2, 1 over 3. First option is E1 less than E2. That is not true. 12 is not less than 3. E1 is equal to twice of E2. E1 is twice of E2. Wrong. E1 is 4 times of E2. Yes. E1 is 8 times of E2 is the wrong. C is my correct answer of this problem. Let x0 and x2. It is given that x1 is my 0, x2 is my 1. Then the sequence xn, which is xn minus 1, xn minus 2 divided by 2. Which of the following statements are my correct? Monotonic. What come in your mind when you think about these terms? That is x minus 1, xn, xn minus 2 are in arithmetic mean. Fine. So what does it mean? If they are arithmetic mean, we can say xn is greater than xn is greater than xn minus 2, or I can say xn minus 1 less than of the xn is less than of the xn minus 2. In both of the cases, we have the monotonic sequence. That means the first answer is the correct option. Now, the shortcut tips for you. How you can find the limit? Because the objective of this lecture is limit. Fine. So remember, whenever you have the sequence of this nature, alpha times xn minus 1 plus beta times xn minus 2, such that alpha plus beta will be my 1, then you can find the limit as n approaches infinity of xn will be beta times x1 plus x2 divided by beta plus 1 if if x2 is my greater than x1. Otherwise, you can interchange beta as here, and this is x1 plus beta times x2 if x1 will be greater than x2. Now you can see x1, x2 is my greater than x1. What is the alpha and beta if you compare from this case? Alpha is the coefficient of x minus 1. Beta is the coefficient of, now you can see alpha plus beta is 1. So what is the answer of this? Beta will be half, x1 will be 0, x2 will be 1, beta will be half plus 1. So what is the right answer of this? 2 over 3 is the limit, and this option is cancelled. Fine. Now since the limit is my unique, so once the limit is unique, that means the sequence is convergent. Fine. Once the sequence is convergent on the real number, then xn is also Cauchy, because on the real we can see both are the same. So the correct option is A, C, D are the right answer of this problem. You can see I have solved each question with the help of the shortcut tricks only for you. Kindly like and comment on this video so that I can also understand that you are watching and learning from my videos. Okay, next one is the limit x approaches 0 2x x e raised to power minus t square of dt. I can return this is divided by x. What will happen if you substitute 0? Lower limit is 0. This number 0 to 0, answer will be 0. So it's a 0 by 0 form. Once it's a 0 by 0 form, I can apply the L'Hopital rule. So what is the L'Hopital rule? You have to differentiate this. The denominator is 1. How you can differentiate the numerator part? That's by the Leibniz. I can substitute e raised to power t instead of the t upper limit into derivative of this minus substitute the lower limit e raised to power x square into derivative of 1. So that means limit x approaches 0 twice e raised to power minus 4x square minus e raised to power minus x square. Now substitute this limit e minus 1. 2 minus 1 is 1 is my right answer of this. Now, look at this another one. Your target is to find the limit of 1 over n factorial raised to power 1 over n. As n approaches infinity, this will go to the infinity, but the inside term is not 1. If it is 1, then we can apply the limit of the fx into gx, but that is not true. Then what you can do is very simple. I can simply choose as a y. I can take a logarithm. It will be minus 1 over n log of n factorial. I can open the n factorial, which is n minus 1 into 1. If I apply the logarithm term, what will happen? It is log of n plus log of n minus 1 plus log of 1. Log of 1 is 0, but fine, this is true. Now, which things come in your mind when you have 1 over n and the sum of the series, like a1 plus a2 plus an? This. Which things come in your mind? That's the Cauchy first theorem of the limit. Cauchy first theorem of the limit. Fine. What he suggested you, if an will converges to the L, then summation of the an over n also converges to the same L. So if I look about this, if I choose an will be my log of n, fine. A1 will be log 1, log 2 and so on. Can you find the limit of this as n approaches infinity? Log of infinity will be infinity. So therefore, this log of y will goes to the minus this part. This is the, by the Cauchy first theorem, also goes to the first term. So y will goes to the e raised to power minus infinity. That will goes to the 0. What is the y is? This part. That means limit goes to the 0 is my right answer. Now again you can see it's the average of this. Again I can apply the Cauchy first theorem. How you can apply that? I can choose an will be n raised to power 1 by n. What is the limit as n approaches infinity of the an? We all remember that limit 1 over n is goes to the 1 as n approaches infinity. This will be 1. So if this will be 1, by the Cauchy first theorem, summation of the an over n also goes to the 1 is my right answer. And you can see this is my unique and existence. That's why the answer is fine. Now, this is my raised to power n. Which things come in your mind when you have a n power 1 over n? How you can find the limit? I can use the Cauchy second theorem of the limit. There are only two limits theorem. First Cauchy first theorem and the Cauchy second theorem on the limit. What is the Cauchy second theorem of the limit is? You have to find the limit of an plus 1 over an. That both the limits are my same. So firstly, I can write this complete in the form of n raised to power. So I can written this is, now what is my an? n plus 1, n plus 2 up to n plus n, that is a 2n divided by n raised to power n. So let's start with the an plus 1 over an. What is the an plus 1? N plus 2, n plus 3 up to, this is the 2n. So if you add the 2n as 2n plus 2, that means 2n, then 2n plus 1, let me write below, this is 2n plus 1, 2n plus 2 divided by n plus 1 raised to power n plus 1 divided by an. An will be n plus 1, n plus 2 up to that 2n into n raised to power n. So clearly say n plus 2, n plus 2, n plus 3, n plus 3 cancel, 2n and 2n cancel. N plus 1, and I can take a 2 common, it will be cancelled. So it will be 4n plus 2. I can take it as a separate, n plus 1 I can separate, n plus 1 into n separate into n raised to power n. Then take the limit as n approaches infinity. This value will be my 4. How you can find this limit? Now clearly say I can write this limit is 1 over 1 over this term. Now clearly say the denominator will be in the form of 1 raised to power infinity. So I can apply this limit as e raised to power f into g, that is 1 over e. So the right answer of this problem is 4 over e is my right answer of this. Let alpha is my 0. I hope you can like my and comment on my video. This term. Then d alpha by dt. First of all, you can't derivative them because limit is my 0 to infinity. It's not from the, if it is from 0 to x or from a to x, then you can differentiate them. So first option is cancel. How you can integrate them? This is my tan inverse from 0 to infinity. It is pi over 2. And clearly say pi is not a rational number. Log of alpha is not true. Only left behind is sine pi by 2 is my right answer of this problem. Let px is a real polynomial of the real value. P is a real polynomial of real variable. That means the roots of the P are real. Fine, there is no complex roots because it's a real polynomial of the real variable, such that P of x will be x a n minus 1 x raised to power n minus 1 plus a1 x minus 1. Choose any number n. If I choose n is equal to 1, then this term will be a0, but there is no a0 present. So I can never choose n is equal to 1. If I choose n is equal to 2, then it is a1. Yes, a1 is present. So what is my px is x square plus a1x, a1x, and the last term is minus 1. Fine. Now, what is the another is, suppose P has no root in the open unit disk. That means this term. That means this px has no root in the open interval minus 1 to plus 1, such that p of that and minus 1 is the root of the equation. Fine. Then p of 1 is 0 or not. Now they are the two roots. So now that's a 10th class question. You have the two roots. One root is my minus 1, other root is say my alpha. Can you find the alpha? The sum of the root will be minus b over a. Product of the root will be c over a. So clearly say from this expression alpha will be 1. If alpha will be 1, what is my a1? A1 will be 0. So my expression is simplified to be minus 1. Clear? Now clearly say what is the root of this polynomial? Roots are my plus minus 1. There are no roots in between. So p of 1 is 0, satisfied. limit as x approaches infinity. What is the limit of x approaches infinity of px? It goes to the infinity. So yes. What is the p of 2? 4 minus 1, 3 greater than 0. P of 3 is equal to 0. Wrong answer. A, B, C are my correct. You can see if you look about that problem is a very complicated, try to reduce them in a very simple manner and you can get your answer based on your 10th, 9th or 8th class study. Now look at that. F is my function which satisfies this property. F of x plus y is fx into fy such that limit of the fx will be my 1 as x approaches 0. Then we will look about the option later on. Can you think about any of the function which satisfy this property? Definitely one option is my this. It satisfies this function. Does it satisfy this? Yes. Fine. So it's a strictly increasing. It's, it's a constant. F1 is greater than 0. They are all satisfied. But based on this counter example, we can't satisfy the problem. Any other effects you can think about? First of all, it's a 0. When x approaches 0, it's a 1. So it is e raised to power something. Does it satisfy this property? Yes. Any other example? Fx will be e raised to power minus x. Also satisfy this function. Any other? You can see 2 raised to power x also satisfied. 3 raised to power x also satisfied and so on. Fine. Now that's are enough to discard the option. F is strictly increasing. You can see if you think about this function, what is the derivative of this case? Minus, this is less than, fine, which is a negative number. So it is not a increasing, that's a decrease. F is a constant or a bounded. If you look about this function, is it a constant? Or if you think about f of x is e raised power, is it a constant? No. Is it a bounded? No. So this option is also cancelled. Fx is my greater than equal to 0. You can see all these functions are my greater than equal to 0. F of Rx is, what is the Rx? That means x is equal to y. Fine. Or you can simply say, what is the f of Rx? Pick any problem. So say e raised to power Rx. I can also return this is e raised to power x. That means fx raised to power r. Similarly, you can pick any of the term, it will satisfy. Fx is always positive because we have the limiting value to be 1. That's a positive of the case. So C and D are my right answer of this problem. Okay, f is my continuous function such that f of x plus 1 is my fx. F is my continuous function. Can you think about any of the function which satisfies this property? Clearly say f of x is my 1. Is satisfied this function? Also it's a continuous. Fine. Then that means a constant function. Every constant function is a bounded below, a bounded above, both. So this option is cancelled. Bounded above and below fine, but may not attain its bound. You can attain its bound. F of 2 is my 1. F of 5 is my 1. So you can attain its bound also. F is bounded above and bounded below, but and F attain its bound. Yes, this is the correct option. F is uniformly continuous. Every constant function is a continuous, but this is the counter one example. Anything else you want to think about? If you closely look about this function, look about this function, which things come in your mind when you think about f of x plus something is equal to same function? Yes, definitely f of x is my periodic function. Fine. If fx is my periodic function, what is the period? Period is my 1. So now, can you think about the function which is periodic? Which things come in your mind when you think about the periodic function? Sin x. But make sure, what is the period of the sin x? Sin x has the period 2 pi. What is the period of the sine? 2x. It will be 2 pi divided by pi. What is the period of the sine? 3x. This is my 2 pi over 3. So can you think about the function fx whose period is 1. That's a simple sine of 2 pi x. Fine. Now if you have a function of this, what is the bounded above? This function is lies between 1 and -1. Again he said not bounded below, but it is a bounded below. Again this option is cancelled. F is bounded above and below, but may not attain its bound, but always attain the bound. So this option is also cancelled. F bounded and attain its bound. Find F is uniformly continuous. Although I will upload the uniform continuous lecture after this based on your likes and comment, but I will tell you the shortcut tips. What is that? If F is continuous plus bounded, sorry, F is continuous, yes, and bounded, or you can say F is continuous and periodic. F is continuous and periodic. This implies F is my uniform continuous. So F is periodic, F is continuous, both are given to you. Bounded, we already proved that in this third option. So that means it is my uniform continuous. Or moreover, you can, that's more than enough. F is continuous and periodic, that means F is uniform continuous. Look at this next one. Fx is a polynomial in the real of degree 5. Can you think about any of the polynomial of degree 5, which is the easiest one? That's a monic polynomial of degree 5. That's over. Limit n approaches infinity, n raised to power 5 over 2 raised to power n. What is that? First of all, you can see that the growth of n raised to power 5, the growth of n raised to power 5 is less than of the 2 raised to power n. Anyhow, if you are not able to understand the growth, this is infinity by infinity form. So I can apply the L'Hopital rule. This is 2 raised to power n into log of 2. It's again an infinity by infinity form. So if I do again, it's a 5 into 4, 20 n raised to power cube. Again, it's a L'Hopital rule. So until you will get term of this, that means you have to differentiate this term by 5 times. Now take limit n approaches infinity. The numerator is a constant, the denominator will goes to the infinity, so the complete term will goes to the 0, and it's a unique and existence. So that means C is my right answer of this problem. F of, okay, S is my minus 1, 2 plus 1. Sin x is my greater than 0. Sin x minus 1 to 4, because I need a minus 1. So can you draw the graph of the sin x? It's a sin pi. Pi is my 3.14. This is my pi. 0, pi, fine. And from this case, it is my minus pi. It's a minus 3.14. It's a minus pi by 2 is my minus 1. What is a minus pi by 2? So the graph will be look like this one. Fine. And since we need a sin x is my greater than 0. So which is the thing? This is the only term which is my greater than 0. Fine. This term is my pi. So what is the s? S is basically my strictly greater than 0. So that means open interval 0 of this. Can you find the infimum of the s? Can you find the supremum of the s? Pi. Now look at that. This option cancel. This option cancel. Only right option is C is my right answer. Always think about the graphically, you will get the right answer in a very, very simple manner. Let xn is a sequence of the non-negative real number. This is given to you. Then limit of the infimum is 0. Okay, again, remember always when you can say the limit existence, when limit of the infimum, limit of the supremum, both are equal, then only you can see the limit is existence. Look at the first part. Limit of the infimum is 0. Can you think about the any sequence whose infimum is 0? Another one is anything. Fine. Then this property is satisfied. What is the xn square? Xn square is also 0 and 1. Fine. What is the limit of infimum? What is the limit infimum of the xn square? 0. What is the limit supremum of the xn square 1. Both are not equal. That means limits is does not exist. Once the limit does not exist, it can never be 0. Fine. The first example is O. Second one, limit of the supremum is 0. So limit of supremum is my 0. What about the limit of the infimum? Can you find the limit of the infimum? Now you can see about that. Since xn is my greater than equal to 0, limit of the infimum will be 0. So once both the limits are same, what does it means? Limit of the xn exists and they are equal to 0. Once the limit of the xn is my 0, then xn square is also 0. So yes, this option is the correct option. Look at the third option. Limit infimum is my 0. So that means I can take an x is my 0, 1 and xn is bounded. You can choose about easily as a unbounded sequence. This is my unbounded sequence. So this is cancelled. Fourth option. Limit infimum of the xn squared greater than 2, greater than 4. That means if I choose a sequence that is which is 2 greater than 2, so I can choose a sequence as 3 3 3 3 3. What is the xn square? Xn square is my 999. So is it satisfied? What is the limit infimum of the xn square? 9 is greater than 4. Does it? What is the supremum of this number? 3. Is it greater than 4? No. So the right answer is only B is my correct answer. Let an is a sequence of the positive numbers such that a1 greater than a2 greater than a3 greater than so. What does it mean? The sequence an is my decreasing sequence. So you can choose any of the decreasing sequence. I can write here. Choose any of the sequence which is decreasing. Fine. Over. Then what is the limit as n approaches infinity? It goes to the 1. That means not goes to the 0. This option cancels. Limit an over n. What is the an over n is? 1 over n minus 1 over n square. It goes to the 0. But this is the one counter example. We can't check the option based on this one. Series an over n. So 1 over n minus 1 over n square. Now we can see this series is my divergent by p test. So once this is divergent, this is convergent, the overall series is my divergent. But he said convergent. Look at the last option. It's a n square. It's a 1 over n square, 1 over n cube. So this is convergent. This is convergent, but we can never check the option based on this one. Fine. You can also think about another example like sequence will be, you can say sequence is n, n minus 1, n minus 2 up to the 1. Fine. Now, firstly we will think about the, because a1 is greater than a2 is greater than an, I can say this is strictly less than of a1. If I divided both sides by n square, fine. Then if I take this summation, because this part is independent of the a, this part is independent of the n. Now you can see this series is my convergent. So that means this an over n square is less than of the convergent series. So by the limit comparison test, this is my convergent. Look at this second option. If it is the option, if it is from the part B, then definitely this will cancel. But it is a part C. Again, an is less than of the a1. If you divide it by n, it is divided by n. Take the limit as n approaches infinity. This value will goes to the 0, and it is my positive numbers. So definitely an over n will goes to the 0. So yes, the B and D are my correct answer of this problem. Okay, let A and B are my natural number. Define, consider the sequence when n is my greater than AB. Convergence when n approaches condition on the A and B. Firstly, I can assume A and B both are equal. What is my Dn? NC1 and C1, that is 1. So therefore, what is the limit of the Dn as n approaches infinity, which is 1, which is unique and existence. That means this is my convergence. When A is equal to B, converge. Take A is my 1, B is equal to 2. That means A is my less than 2. Then what is my Dn? NC1, NC2. That is n minus 1 over 2. So clearly say when you take n approaches infinity, this will goes to the 0. Again, it's a unique and existence. That means it is convergence. So whenever A is less than B, converge. Look at that, A is greater than B. I can choose A is my 2, B is my 1. So Dn will be NC2, NC1, n minus 1 over 2n. So that will goes to the infinity. That means does not exist. Once this is does not exist, it means it is not convergent. It convergent for all the values of the AB, but clearly say whenever A is greater than B, it is not convergent. So the right answer is B and C are my correct options. Okay, look at this another one. Lambda n is given to you is existence for some does not exist. So I can integrate them. What is the integration of this? 1 plus t raised to power 1 minus n over 1 minus n from 0 to 1. I can say it is my 2 raised to power 1 minus n minus 1 over 1 minus n. So therefore, lambda n will be my this now. Fine. Now clearly say this is existence for all n. But what about the n is equal to 1? We will check whether the limit existence or not. So let's see what is the limit as n approaches 1. 1 minus 1 0, 2 raised to power 0 1. So it's a 0 by 0 form. I can apply the L'Hopital rule. So 1 into log of 2 into derivative of 1 minus n divided by minus 1. When n approaches 1, it's the 2 raised to power 0 1. So that will goes to the log of 2, which is my finite. Once it is my finite at n is equal to 1 and also existence and unique for all n. So therefore, this sequence is my convergent for all n. So does not exist for some cross. Existence for every, but the sequence is unbounded. That's wrong because it has a finite sum. So sequence is my bound. Now look at this term. Again, your target is to find the limit. As what come in your mind when you have the limit power 1 by n. Again, the Cauchy's second theorem. Fine. So that means we need to find the limit of n plus 1 over lambda n. Can you calculate the lambda n plus 1? What is the n plus 1? It will be my 2 raised to power minus n over minus n into 1 minus n over 2 raised to power 1 minus of this. Now clearly say if you take limit n approaches infinity, this value will be my 1, fine, and this other value 2 raised to power minus 1, 2 raised to power into this is my 1. So when you take n approaches infinity, this term will goes to the 0. So this value will be my minus 1. This value goes to the 0, minus 1, that is plus 1. So by the Cauchy's second theorem, this is also plus 1. So C and D are the right answer of this problem. Now A, B and C are my sum sequence which are sufficiently large. That means you have to find the limit as n approaches infinity. An over Cn. A and C. So these are my constant. I can simply take the proportional of 2 raised to power n over n square. What is the limit as n approaches infinity? This is my L'Hopital rule, infinity by infinity. 2 raised to power n, 2 raised to power n, then log of 2 divided by n square. What is the derivative of the n square is 2 into n. Again, it's a L'Hopital rule. So log of 2 square over 2, that will goes to the infinity. Once it will be infinity, that means a over c is my greater than 1. That means a is increasing more than of the c. Similarly, you can check about the b over c. What is the b over c? B, that is the log of n over n square. Again, it's infinity by infinity form. 1 over 2n, that is 1 over 2n square. It goes to the 0. That means b growth rate of the b is less than of the c. Bn is my greater than of n. I can divide b by n. That is log of n over n. Again, it's infinity by infinity. So that will goes to the 0. Therefore, b is less than of n. Now a is greater than of the b. So clearly say from equation number 1, from equation number 2, b is less than c is less than of the a. So a is greater than b is the correct one. Otherwise, you can find a over b also. If you take a over b, it's a 2 raised to power n over log of 2, log of n. Fine. Now if you differentiate them, 2 raised to power n log 2 over 1 over n. N is our and it will be infinite. So the right answer is A and B are the correct answers. Now f is a bounded function. A belongs to the R such that this will be occur. Okay, it is given only as a bounded function. Bounded function may be a continuous function, may be a discontinuous function. If you look about the last option, it is given that it's a continuous. It means for the other part, I can think about the any discontinuous function. So let's say any number is 4 when x is equal to say 2, or say when x is equal to 1, otherwise 0, else 0. Clearly say this function is my bounded. Fine. Then your target is to find the w of a. I can choose a is my 1. Fine. So then what is my w of 1 comma in delta? Supremum of fx minus f of 1. What is f of 1 is 4. So can you calculate the supremum of fx minus 4? It comes to be 4. Fine. So it's a 0. Yes. Does need not exist, but its existence. So this option is also cancelled. This example is not applicable for this because we need a continuous function. Now look at this example. What is the meaning of this is, if I choose, for this case, I can choose say a is equal to 0. Fine. Then I can choose another example, say a is equal to 0. So this number will be my minus delta 1 to plus delta 1. Now since if delta 1 is less than of the delta 2, that means this is my quantity. So this is my delta 1 and the complete is my delta 2. So definitely the supremum of omega corresponding to the delta 2 is my this part, and supremum corresponding to the delta 1 is my this part. So from the diagram you can easily see supremum of the delta 2 is always greater than of the supremum of delta 1. That means omega of a comma delta 2 is greater than of omega of a comma delta 1. So first option is the correct option. Now the last option, if f is continuous function, if f is continuous function, what does it means? That means limit fx when x approaches a is my f of a, or you can also say fx minus f of a is less than epsilon whenever x minus a is less than delta. And you can see I can write this quantity in terms of x minus a is less than delta. Now once this number is less than of the delta, so that means supremum of this, that means omega of a comma delta. Fine. So now if you take the limit on this omega, when you take the limit as delta approaches 0 positive, that means this x approaches when it will the delta is 0, that means x approaches a. Once x approaches a, this the fx approaches towards the a, that means this number will be 0. Fine. So if f is continuous, then this will be 0. I can also do the same part. If this part will be 0, what does it means? Supremum of the fx will be equal to the f of a. That means the function is continuous. A and D are my right answers. Now look at this another one. Again, they are talking about the limits at x is equal to 0. What does the meaning of this? Limit supremum and infimum. What is the limit of the fx? Limit x approaches 0, sin x and sine of 1 over x. So clearly say when x approaches 0, this part will be 0, this part is my boundary. So what is the right answer? 0. So once the limit will be 0, this is unique and existence. So therefore, limit of the infimum and the limit of the supremum both are same, and it must be equal to the fx, that is 0. First option correct, second option cancel, third option correct. A and D are the correct answer of this problem. I hope you can like and comment on my this video too. Now look at that. This is the question related to the infimum and supremum. Fine. Or always remember my shortcut tricks. Whenever you will see the term minus 1 raised power n and the limit, both have the same term, fine, both in the same question, then I recommended you firstly, you must watch my previous lecture on the infimum and supremum. You must watch about my PY questions on the infimum and supremum. You must watch it and you can learn the various shortcut tricks. So I can apply the same. Whenever you will get the minus 1 raised power n, always discretize this when n is even, when n is odd. Always. Fine. You will get your answer within the 5 seconds. So when n is even, this number is positive, I can separate it. It is pi over 2 plus 2 will be cancelled out. It's a e over n. When n is odd, it is pi over 2 minus of this. Then take the limit. What will be the limit as n approaches infinity? So the answer will be pi over 2. Both the cases pi over 2. Fine. So what will be the supremum of this limit? Pi over 2. Infimum is also pi over 2. Now substitute value in the first case. Limit supremum. What is the limit of the supremum is? Pi over 2. Exponential cos pi over 2. What is the cos 90 degree? 0. E raised power 0, 1. Does it strictly less than 1? No. This option is cancelled. You can see this is the same question. Fine. What is the limit infimum? Limit infimum is again pi by 2. So e raised to power sine pi by 2. E raised to power 1 is a e, that is 2.718. Does it less than of the 3.14? Yes. Look at this case. Again, I will choose the two options. One is the n is even, second n is odd. When n is even, if I break them, it is pi square by 7. This is a positive number. It is e square over 7n. When n is odd, this is pi square minus e square over 7n. Then take the limit as n approaches infinity. Both times I will get as pi square by 7. So this is the limit of the supremum. This is the limit of the infimum. So now look at the option. What they suggested you, limit exponential raised to power log of this. That is the limit infimum and supremum both. So what is the answer of this? Pi square by 7. That's the unique and existence, but he said does not exist. Look at the last option. Again, the function is same. Limit exponential tan pi square by 7, which give you the unique and existence. But again, the last option suggests does not exist. So the right answer is B is my Correct answer. And you can see this is a very recent year paper. Again, it's a infimum and supremum. Look at the first option. Firstly, take n approaches infinity. Answer will be 0. It's a unique. Fine. It's a unique. Once we know the unique, then the limit infimum and the limit supremum both are equal. So it's a supremum. It's also the infimum. So you can see 0 is equal to minus 0. Satisfied. It is minus 1 raised to power n. I have taken the two cases when n is even, when n is odd. When n is even, it is this quantity. When n is odd, this is my. When you take the limit as n approaches infinity, the answers are 1 and minus 1. This number is my supremum. This number is my infimum. Fine. So that means limit infimum is my 1. This is my minus 1 of 1. That's again satisfied. Look at the third option. Again, I will do the two cases. N is even, n is odd. When n is even, it is my 1, it is my this number. Take the limit as n approaches infinity. Answer is always 1 and 1. That means supremum and infimum both are same. That is satisfied. 1 is equal to minus 1, not satisfied. Look at the last case. It's the upper interval. So the infimum is my minus 1. Supremum is my plus 1. Clearly say it is my satisfied. So the right answers are A, B, D are my correct answers of this problem. Now you can see it's again the December 2023 is a very common. Again you have that 10 minus 1 raised to power n. I will choose n is even, n is odd. Whatever the year, whatsoever the year, whether it's a 2011, whether it's a 2023, whether it's a 2024, whenever you will see minus 1 raised to power n and the limit, always do like this method. When n is even, this is a positive. So if you do the calculation, you will get 5 n by 6. When n is odd, it is a negative. And when you calculate them, it is a n pi over 6. Fine. Now, limit supremum of the an. Now you have to apply the cos of 5 and pi over 6 and cos of minus n pi over 6. What is the supremum of this? Because it's a cosine, the supremum will always be 1, but it's a root 3. A of 2n. 2n means that is an even number. So that means this quantity. What is the supremum of this quantity? That's a 1. Fine. What is the supremum of the even number? It's a half. Wrong. A raised to power a3n, that is a3, a6, a9, that is a odd and even both. So that means we can consider both the terms. What is the supremum of these quantities? Both the quantities are less than equal to 1. So it's a 0. That's a wrong option. So correct option is only B is my right answer. Again, you can see it's a 10, it's a minus 1 raised to power n. If n is even, then it is my 1 plus 1 over n. When n is odd, it is my 1 over n raised to power n. Then can you take the limit as n approaches infinity? Now clearly say it is my 1 raised to power infinity form. I can use the e raised to power f into g. So what is the limit? E raised to power 1, e raised to power minus 1. This is my supremum. This is my infimum. So the last option is the correct option. Rest are my wrong. Kindly support my videos by like and comment on this. F is my bounded function. Can you choose any of the bounded function? Every constant function is my bounded. Always, whenever you provide the counter example, start always from the constant function. Then, what is the supremum of the Fn? Is my 1 because the limit is my unique. That's the limit existence. Then infimum and the supremum is my same. Now the first one is 1 belongs to the n. That's a correct statement, but we need a not correct statement. Infimum is 1. 1 is also the part of the natural number. Fn plus n. Fn is my 1. 1 plus n. What is the supremum of this? Infinity. Infinity is not the part of the n. Yes, it is my true statement. The only left option is C is my right answer of this problem. Again, you can see it's a -1 raised to power n form, and they are talking about the limits if n is even and n is odd. If n is even, so this quantity is 5 over 2 raised to power n. This is the positive number. This is my positive number. When n is odd, then this quantity is my -5 over 2 raised to power n. This number is my negative, -1 over 4. This number is also negative, minus minus plus 2 over n. What is the limit as n approaches infinity? This value goes to the 0. This value goes to the 0. So this number will be 12 plus 1, 13 over 4. And the below one is again this goes to the 0. This goes to the 0 as n approaches infinity, 11 by 4. This is the minimum value, that's the infimum. This is my supremum. So the second is my right answer of this. Okay, that's a very simple. Firstly, I will give you the shortcut tricks and then I will give you the counter example. Limit of the supremum an plus bn is always be less than of the limit supremum of an plus limit supremum of bn. But what is the limit of an minus bn? It is less than or equal to limit of an plus, because of this negative, it will be my limit infimum of b. Fine. Similarly, what is the limit infimum of an plus bn? It will be greater than or equal to limit infimum of an plus limit infimum of bn. Similarly, you can write as a negative sign. So clearly say the first option is correct by this statement. Second is my wrong. Third is my wrong. Fourth is my correct statement. Fine. Otherwise, you can also think about the example. Let's say xn is my fine. Since I need a xn plus yn, I can choose yn is this number. Fine. What is the xn plus yn? 0. So now it's a unique number. So the limit is my 0. What is the limit supremum of xn? 1. Limit supremum of, so 0 is less than 2. 0. Limit supremum of xn? 1. Limit supremum of xn. So 0 is greater than of the two wrong options. And we can see out of them, one option is the correct because they are inequality signs. So B is cancelled, A is correct. Limit infimum 0. What is the limit infimum of this? -1. Limit infimum of this -1. So 0 is less than equal to -2 wrong. 0 is greater than equal to -2 correct option. So A and D are the right answer. Look at this another one. An and Bn are the two bounded sequence. Which of the following are my correct? Again, you can see limit supremum. Either this number is my positive or this number is my negative. Fine. So this will be equal to, can never be. What is the result is? When it is a positive, then limit supremum supremum. When it's a negative, then it's a limit infimum. So since it involves both, limit supremum, limit infimum is the right answer of this problem. So this result is not applicable when n is my odd. Fine. So this stops. Otherwise, again, you can choose the same example. -1 raised to power n. Bn is my bounded sequence. You can simply choose this one. Or again, -1 raised to power n. And you can see that again, this result will not be applicable. So the right answer is my only C is the correct option of this problem. This is limit may not exist, but you can provide the counter example. You can see if I choose an is my bounded sequence, bn is my -1 raised to power n. Then what is the value of this? This number will be my 2. And it's a, what is the limit supremum of the constant value? Limit supremum is again 2. That means it's a unique and existence. He said may not exist. Cancel. So the right answer is only C is my correct. I hope you have learned many tricks to solve this PY question on the limits. I hope you can support by like, comment and share this video with your friends. I will come up with my next lecture on the PY question of the continuity. Till then, best of luck students. Happy learning.